next 5 5 3 asterisks again, and this is simple but also good enough problems, so you should recognize its importance and please get the good mindset to understand after understanding this problem. So this is the first trial, and this is the next trial, and this is a problem. One is stable and the other is minus b towards the one, and in this case the same mass collide each other with the same speed, and after collision separate each other the same amount of velocity, some speed, and in this process the kinetic energy of times F is lost. The loss is total kinetic energy mv square minus mv square F equal mv square 1 minus F. So v prime is v times square root 1 minus F near equal v times 1 minus half F. This is described as shown in the problem notes, and the problem is two equally massive gliders moving on a level air track at equal and opposite velocities v and minus v, glide almost elastically and rebound with slightly smaller speed, slightly smaller, v prime equal v minus delta v. Delta v is the residual one, and then they lose a fraction f much more than 1 of their kinetic energy in the collision. Use these same gliders collide with one of them initially at rest. With what speed will the second glider move after the collision? This small residual speed may easily be measured in terms of the final speed v of the original stationary glider, and thus the elasticity of the spring bumpers may be determined. If x is much smaller than 1, then square root 1 minus x near equal 1 minus half x. This. This is k0, coordinate k0. From the view of the one which has velocity of the same one as v, this glider looks stable, velocity 0, and this the other one is minus 2v, and this is coordinate kv. In coordinate kv, the collision after the collision, each velocity is like this: minus v prime minus v prime minus v, v prime minus v, and v prime is v minus delta v, so equal, this is minus delta v equals from this minus half fv. You can recognize this is after collision, this one has the residual velocity in kv, and this is a set of this problem. the same glider, one is stable and one is minus b. What the velocity each other minus b prime double prime b prime double prime equals. Actually, in this insight, transformation of the coordinate after that, this is given, and we got these, and from this minus 2b exchangeable to minus b. So minus 2b, then this one is minus v prime plus v, and this one v prime minus b. So exchange large v equals half v, and then v prime and v minus half fv, but in v that small v prime equals small half v, sorry, and so in this case half fv equal delta v and vf equal 2 delta v over v, but in this small v, lowercase v, v is given, small lowercase v is given, and residual velocity is this is the one, and this is the residual velocity. V prime minus v equal half v, but v equal half v, so quarter of fv is the residual velocity. A little complicated, but delta v nearly equal fv over 4.